In section 7.4, we're going to be looking at rational exponents and how to simplify expressions that involve rational exponent. So in this section, we're going to be using our properties of exponents along with using the rational exponents themselves. And I want to point out that our rule for rational exponents is this down here. A rational exponent is an exponent that can be written in fraction form. And basically what the fraction as an exponent tells you is that you can use your denominator to indicate the root of a particular expression or base. And if you have a numerator as well, that not only indicates a root as well as a power that you're using in combination with each other. And then we have all of our regular basic rules of exponents, including that for a negative exponent, which makes a reciprocal of that particular power, not a negative, but a reciprocal of the number. And then again, like I said, all of our normal rules of exponents that we would normally use. All right, so I have a few examples that I've selected that I'm going to work out for you here, and I'm going to start with just a few. The first one I'm going to have just a regular radical that I want to show you how we can convert from a radical form to an exponential form using our rules of exponents, using our rule down here at the bottom of the screen. So what I would do is basically take the two pieces that I have here, my root and my exponent, and make those into the fraction that I'm going to use as my exponent for my base x. So in this case, my numerator is the power, that's a 5. And my denominator is the root, which is the index of my root, which is 3. So to convert this, I keep my base as x, just like I have inside my radical. And then I use my 5 as my numerator for my exponent and my 3 as my denominator. So what I've done is change this from its radical form to its exponential form. Now I can also use that to do that in reverse order. So I could take something like 16 to the 3/2 power, and to help me evaluate this, let's say if I wasn't using my calculator or if this was a variable and I needed to put this in its radical form, I could do this a couple different ways, but I would start with my root, which happens to be a square root because my denominator is 2, and my power, which is a cube root. Now, since I do have a 16 here, I am going to, in my case, decide to do the root first, like this example here, and then take care of the power, the exponent. And the reason for that is because I know that 16 and square roots will work together very nicely. So how I'm going to do mine is I'm going to do my square root of 16 first, and once I calculate my square root of 16, then I'm going to take that to the 3rd power. So when I calculate the square root of 16, I get 4. So this actually makes 4 to the 3rd power, and then 4 to the 3rd power ends up being 64. Okay. Now, if that would have been an x, I would have just simply written it as the square root of x cubed and maybe simplified from there. Okay, so that's those two examples. Now I want to do a couple more examples using my properties of exponents. And the first example that I want to do for you here is just using a basic property of exponents along with a couple of rational exponents. So I want to do x to the 2/3 power times x to the 1/2 power. Now, according to this, I want to combine this and simplify this. And if you look at your properties of exponents up here at the top, if you're looking for a property that would fit this example over here, I would be looking at this property right here, where I have the same base with two exponents. The two powers are being multiplied. And according to the rule, it says I need to add the exponents together. Okay, well, just because the exponents are rational, they're fractions, doesn't mean that I treat them any differently. The rule says to add, so I'm going to add. Now, you can do the addition in our case with the calculator, or you can get a common denominator and add them together. No matter how you do the actual calculation, a half plus 2/3, if you add them together, a half plus 2/3 is going to give me the fraction 7/6. So I end up with a final answer of x to the power 7/6. And again, like I said, it doesn't matter if they're integers or whole numbers or whatever they are. The rule says to add, so I'm going to add. And whatever the result is that I get, that's what I'm going to stick with. Okay, now let's look at another. We're going to combine a couple of different properties here in this next example. And I'm going to do this problem. 36x to the 12th, y to the negative 6th. And then all of this is going to be to the 1/2 power. So I'm going to have to use a couple of different properties here. But the first property that I'm going to use is actually this property right here, because inside this parentheses I have a product. I've got a 36, I've got an x to the 12th, and I've got a y to the negative 6. So anytime you have a product inside your parentheses with an exponent to the outside, you're going to simply take that exponent and apply it to each part of your product. Now I happen to have 3 parts to my product, so I'm going to end up with this. The first part of this, okay, this is like I always say, you're going to have to break this down into each piece and then decide what to do with each of the parts. Okay, so the first part is the 36. So I'm going to take that to the 1/2 power. Then I'm going to have to take the x to the 12th to the 1/2 power. And then I'm also going to have to take my y to the negative 6th to the 1/2 power. Okay, so now when I look at each of the pieces, starting with 36 to the 1/2 power, that looks like this down here, right? X to the 1/n power. And that just simply tells me to take that root of that number. So in other words, over here, I am actually going to do 36, the square root of 36 because of the 1/2 power. So the square root of 36 is simply just going to give me a 6. Okay, so now the next part though, if you look at it, x to the 12th to the 1/2 power, I need to look at my properties and see what property applies when you have a power inside your parentheses with an exponent to the outside. And that happens to be this property here. See, I have my power inside with my exponent over here, says to multiply the two together. So when I come over here, 12 times 1/2, and I multiply those two together, is going to leave me with x to the 6th. Okay, and then finally, so the y part over here has the same property that I just used. This time it's a negative 6 times a 1/2. So a negative 6 times a 1/2 is simply going to give me a negative 3. If I'm looking at all these pieces together here, the last thing I want to do is I do have a negative exponent, and according to this, my properties tell me to go ahead and do the reciprocal of that. So that's actually going to end up being 1/y to the 3rd power. And don't forget to make your exponent positive once you do the reciprocal. So now if I just put each of my pieces together here, my 6, my x to the 6th, and my 1/y to the 3rd, I'm going to end up with a final answer that looks like this. I'll have a 6x to the 6th in the numerator, and in the denominator I will simply have a y to the 3rd. Okay, now I have one more example that I want to work out for you here. This example is going to look like this. Again, it's going to involve multiple properties to work with. I'm going to have 8x to the 6th over 27y to the 12th. And I am going to be taking this entire fraction to the 2/3 power. So one step at a time, one property at a time is what I'm going to deal with. And so the first thing that I'm going to deal with is the fact that I have a quotient inside my parentheses with an exponent to the outside. So to do that, this tells me that this fraction is going to be separated like this. The numerator will be to the 2/3 power. And then separately, I'll do the denominator also to the 2/3 power. Now, when you look at the numerator to the 2/3 power, there's still a product inside here. So according to my rule about a product, each part of that product also needs to be taken to that power 2/3. So let's do that part of it. So I'm going to get 8 to the power 2/3. and I'm going to get x to the 6th to the power 2/3. And I'll do that to my denominator as well, so 27 to the power 2/3, and also y to the 12th to the power 2/3. Okay, so let's take care of each of those parts. 8 to the power 2/3, you can do that with your calculator, or you can do that yourself. Cube root of 8 is 2, 2 squared is 4, so I end up with a 4 from my 8 right there. Then my x to the 6th to the 2/3, like we did in the last problem, 6 times the power, or 6 times 2/3 is going to give me a power of 4. Okay. Now on to the denominator. So I have 4x to the 4th in the numerator. Onto my denominator, 27 to the power 2/3 is, the cube root of 27 is 3, and 3 squared is 9, so that's going to be 9. And then this one, 12 times 2/3. I'm multiplying the powers together because of my rule over there. 12 times 2/3 is going to give me a power of 8. Now, just like with any other fraction, you want to double check your fraction, make sure there's no reducing, no like terms that need to be reduced down. 4 and 9 don't reduce, x to the 4th over y to the 8th doesn't reduce, so everything is simplified as much as possible, and my final answer would be 4x to the 4th over 9y to the 8th.